Welcome to Elimu TV, where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 3, lesson number 26. And our title is Equations of Linear Motion. The objectives of this lesson are to derive the three equations of linear motions and use them in solving mathematical problems. What is linear motion? From the word linear, we come to understand that it involves a line following a straight line. Now, linear motion means movement in a path that is straight. So there are no curved bends or any other. It's linear motion. So the path is very straight. It's a linear motion. So that is the meaning of linear motion. Next, we have equations of linear motion. And some of the equations of linear motion are V is equals to U plus AT. And how do we find that equation? First, acceleration is equals to V minus U all over T, as you can see from the diagram. A is equals to V minus U over T. So V is equals to U plus AT. Multiplying A by T is going to give us AT is equals to V minus U. Now, taking the U the other side, we're going to have V is equals to U plus AT. That is the first equation. The second equation is S is equals to UT plus a half AT squared, as you can see from the diagram. And how do we get that equation? The displacement S of a body is given by the average velocity times the time, which is U times V over 2 times T. But V is equals to U plus AT. Therefore, S is equals to U plus AT all over 2 times T. And that gives us 2U plus AT over T times T. As you can see down there, S is equals to UT plus a half AT squared. That is the second equation of linear motion. The third equation of linear motion is V squared is equals to U squared plus 2AS. And how do we come about that equation? We can see that V minus U is equals to AT. Hence, S is equals to UT plus a half AT squared. V plus U over T times T. And T is equals to V minus U over A. Displacement S is given by V plus U over T times V minus U over A, which is V squared minus UV plus UV minus U squared all over 2A. That comes to 2S is equals to V squared minus U squared. Therefore, the equation comes as V squared is equals to U squared plus 2S. Therefore, we have three equations. The first equation is V is equals to U plus AT. You can see it from the diagram. The second equation is S is equals to UT plus a half AT squared, where U is the initial velocity, V is the final velocity, A represents the acceleration, and T represents the time taken. The second equation is S is equals to UT plus a half AT squared, where S is the distance or the displacement. And the last equation is V squared is equals to U squared plus 2AS, where V is the final velocity, U initial velocity, A is the acceleration, and S is the displacement. And also the displacement, S is the area under a velocity time graph, whereas the acceleration is the gradient of a velocity time graph. Next, for retardation, A is negative and thus changes the positive sign in any of the equation. Let's say the acceleration is negative. That means there is retardation, and retardation is given in positive way, but acceleration is given in negative. Let's say we have a retardation of 2. That means the acceleration is negative 2 meters per second squared. A question. A body starts from rest and with a uniform acceleration of 10 meters per squared second for 5 seconds. During the next 10 seconds, it moves with uniform velocity. Find the total distance traveled by the body. This is our solution. Since u is 0 meters per second, because the body is starting from rest, a is 10 meters per square second, the time is t, which is 5 seconds. The equation we're going to use there is v is equals to u plus at, whereby v is equals to 0 plus 10 times t, which is 5, which will give us 50 meters per second. The distance traveled in the first 5 seconds is s is equals to ut plus a half at squared, which is 0 times 5 plus a half times plus a half v plus 10 times 5 squared, which is 125 meters. The distance traveled in the following 10 seconds is going to be the total distance traveled. S1 is equal to VT1, which is 50 times 10, which is 500 meters. Therefore, the total distance traveled is D is equals to S plus S1, which is 125 plus 500, which is 625 meters. Next question. A cat rolling down an incline for 5 seconds has an acceleration of 4 meters per second squared. If the cat has a beginning speed of 2 meters per second, what is its final velocity? Here, the solution. Applying v is equals to u plus 80. All the symbols are bearing their conventional meaning. Therefore, u is equals to 2 minus 1. T is equals to 5. A is equals to 4 meters per second squared. Therefore, so we are going to have v is equals to 2 times 4 times 5, which will give us 22 meters per second. There u is 2 meters, back 2 meters per second. Activity. And that is the end of our lesson. I have a question for you. A body moving with a uniform acceleration of 10 meters per second squared covers a distance of 320 meters. If its initial velocity was 60 meters per second, calculate its final velocity. Our reference comes from KLB Book 3, 5th edition, 2019 Physics. For more information, contact us on our phone number, YouTube, Elimu TV, Facebook, Elimu TV, and Twitter at Elimu TV _KE. Thank you for watching Elimu TV.